Hi and welcome, ladies and gentlemen. Today we are talking about selection sort. Well, selection sort is an algorithm for sorting data that is sequentially running through the data, finds the minimum in a subway, and then does a compare and swap operation to swap the items so that it gets sorted. Alright, it is an in-place sorting algorithm. That means that it sorts the data without the need of more memory or something like that. So it can be used for really big data sets too. It has a time complexity of n squared in average and in worst case. Alright, so let's have a look at the algorithm. Well, at first we set the index to our first element in our data array. And then we run through the other elements of our data array and find there the minimum. And then we compare our data element at our first position with the data element at our minimum position. And if that is bigger, then we swap our data element at our index position with the one at our minimum position. Alright, in the second step, we would go set our index to the next position and then use the rest of the array. So basically we are sorting from the beginning, find the minimum and insert it at the beginning. Alright, we have here the example where we have an initial list of 75, 38, 42, 1 and 10. So we set our index at 75 and our minimum at 38. Then we check is 38 smaller than 42? Yes it is, so we don't have to do any swap operation there or set our minimum somewhere else. Alright, the next step would be comparing 32 and 1. And 1 is smaller than 38, and so we have to set our minimum to 1. Alright, and in the last step for this run, we compare the 1 with the 10, and that is smaller, so we don't have to set the minimum somewhere else. Alright, in the next step we compare the 75 with our minimum, and that is 1. And we figure that 1 is smaller, so we have to swap these two. Alright, so run 2, or here the index at position 1. We set our index to 38 and our minimum to 42. Now we go through 42, 75 and 10 and find there is a minimum. For that we compare 42 and 75, that is where 42 is smaller. So we don't set the minimum to 75 and then the same with the 10, but here we set the minimum to the 10. Alright, now we compare the item at position index, which is here 38, and our item with the minimum, and that is 10, so we compare 38 and 10, and that is smaller, so we have to swap here. And as you can see, the first two elements are now swapped in our data array. So now we just have to have a look at 38, 75 and 42. And there we set our index to 38 and then our minimum to 75. So now we have to compare 75 and 42. 42 is smaller, so we have to set our minimum there. And then we don't have to swap 38 with 42 because the item at index is smaller than our minimum in the rest of the array. Alright, so we just have to do the 75 and the 42. We set our index to 75 and our minimum to 42, and that is also the minimum of a single array or item. And then we see that 75 is bigger than 42, so we have to swap these and we end up with a sorted array. Alright, so let us implement that in Python. At first, I create a class called Selectionsort, and there I create a method called swap that gets the data array and two indices that need to be swapped. Expects a data array and two indices and returns a copy of the data array with I and j swapped. Alright, so let us do the swap operation. For that we need a temporary variable, set this to one of the two data points we want to swap, and then we set the data point, which is now in our temporary variable, also to our other data point, and then we can set our other data point to our temporary variable, and then we just need to return our data array. Alright, let's do our sort operation now. So we receive there just our data array, and we say we expect a data array or a numerical data array, and it returns the data array sorted in ascending order. Alright, so at first we need our index element, and that we set to null at the beginning. And then we have to go through our data until our index is the second smallest element. So we have to use here our length of our data array, and length of our data array gives us the number of elements. So this would -1 would be the last index, and -2 gives us the second last index. And then we have to say index plus equals 1 somewhere at the end. Alright, now we just have to find our min. For that I set our min to our index plus 1. And then I go in and say for I in range. And we want to start I at min. And it's supposed to go to length of our data -1. And then we have to check if our minimum element is bigger than the element at position I. So data min bigger than data I. Then we say min equals I, and so we get our minimum element here. Alright, so what we have to do then, we just have to check if our data of our index is bigger than data of our minimum. And then if that is, then we say data. Then we need our swap operation. Swap data, index, and min. Alright, that should be it if I'm not mistaken. We forgot one small thing, and that is returning our data array. And that looks good. So let's try that. If the name equals main, then we create a sorter variable, and that is Selectionsort, new instance of our class, and then we need a data array, let's say 99, -1, -5, 17, 42, and 23. And then in the end, we say sorter.sort our data. And because we just want to check if it is right, we just print it. Alright, here is now a mistake somewhere. It says the bracket wasn't closed because I missed a comma here. Alright, let's try this. And that looks good, minus 1742. And it didn't do the last item. Yeah, the range gives us, or excludes the right interval limit. So let's try it again, and that looks good. Minus 5, 1, and that are 6, and that are 6 too. Alright, we can add a few more here just to see if it really works. 75, 54. And there we take 43. And that looks perfectly fine. Alright, ladies and gentlemen, that was it for that video. If you liked it, give it a thumbs up, and if it helped you, subscribe to the channel to get informed whenever I'm uploading new videos. So, have a great day, bye.